Hey, Algebra 1. I wanted to do a quick lesson here on geometric sequences. You should have your note sheet handy, and just make sure you go ahead and pause as you need to keep up with the notes. So we are doing geometric sequences today. We already did arithmetic sequences, if you remember those. So let's start with what is a sequence. A sequence usually is just a bunch of numbers that follow some sort of pattern. So this first sequence here of 4, 5, 6, 7 clearly follows a pattern that we are adding 1 each time. So that is an arithmetic sequence because we're adding the same amount each time. The next one, 1, 4, 9, 16, you may notice a pattern there that's actually all the perfect squares. So that's a different type of sequence where we just are listing all the perfect squares. The third one, 3, 6, 12, 24, take a minute and see if you can figure out that pattern. And hopefully you can see that we are multiplying each one by 2. And that is a geometric sequence. So when we are multiplying each number by a constant term, then that is a geometric sequence. So if we look at our next column here, the geometric sequence, we have a pattern here of 3, 12, 48, and 192. And those have a common ratio. If it's a geometric sequence, then they have a common ratio, and we use R for that. And that ratio is what are we multiplying by? So each time we are multiplying by the same amount. And if you're not sure how to calculate it or you can't see it, you just take the second term divided by the first term. So 12 divided by 3 should be the same as the third term divided by the second term. 48 divided by 12 should be the same as the fourth term divided by the third term. 192 divided by 48, and those are 4. So each time here we are multiplying by 4. And so 4 is the common ratio. That is R. So we've got some different notation here from when we did arithmetic. G sub 1, that just means for a geometric sequence. That's what the G stands for. The 1 means first term. So this is just saying what is the first term in the geometric sequence. And in this case, it is the number 3. G sub 2 follows that same idea. That is the second term of the geometric sequence, which is 12. G sub n is how we generically write some other term. So we call this the nth term, and that is unknown and usually what we're trying to find. So a lot of what we're doing revolves around the nth term, some unknown term. So just like in arithmetic, we have recursive and explicit formulas. So these two formulas are super, super important. They will be given to you on your test, but they are specific formulas for geometric sequences. And those give you a way to write G sub n. Notice both recursive and explicit are G sub n. So on this first one, it's a way to find the nth term. The recursive formula is a way to find the nth term, and we need R, and we know that R is 4. And so we plug that in, and we can say that G sub n, the nth term, is 4 times G sub n minus 1, which is the term before the nth term. So this is our recursive formula. But all that is saying is to find the nth term, you're going to take 4 times the previous term. That's all that is saying. The nth term is 4 times the one before it. Now the explicit formula is going to use G sub 1, which we know is 3, and R, which we know is 4. And so to plug into that formula for G sub n, so another way to find the nth term is to take G sub 1, which is 3, times 4 to the n minus 1. So that is the explicit formula. Now, both of those we can actually write also in function notation. So instead of using g sub n, we are using function notation, which is f of n. So if you want to use the recursive formula to find the nth term, it's going to be r times the term before that. So it's the same as our recursive formula. It's just written in function notation. And another way to write that is instead of finding the nth term, we sometimes say, how do we find the n plus 1 term or the next term? So f of n plus 1 is going to be r times the term before that, and the term before n plus 1 is just n. So those are really similar formulas for function notation. Now we can also do function notation with our explicit formula, and we just use f of n instead of g sub n. So f of n is 3 times 4 to the n minus 1. And we're just writing that in function notation. Function notation just means we're going to call it f of n or f of n plus 1. Okay, let's do some examples. All right, our first example here is the sequence 5, 10, 20. Now, hopefully when you look at that, you can figure out what that pattern is. How do we go from 5 to 10 to 20? And if you're not sure, you can calculate it, but hopefully you can see that what we are doing here is multiplying by 2. And so 5 times 2 is 10, 10 times 2 is 20, 20 times 2 is 40, and 40 times 2 is 80. So if you can see that pattern, we're just multiplying by 2. That's a geometric sequence. So what is part A is what is g sub 1? That just means first term. That's 5. Part B, what is g sub 2? That means second term. That's 10. What is r? That's what you're multiplying by. That is the common ratio. And in this case, we know that it's 2. But if we didn't know, we would take the second divided by the first. 10 divided by 5 should be the same as 20 divided by 10. Should be the same as 40 divided by 20. It's a term divided by the one before it, and those are all 2. So r is 2. So we've got a bunch of numbers there. What would be the next number in the sequence? That would be 80 times 2. That's 160. What is the next number? That would be 160 times 2, which is 320. So part F says write a formula to find the next term in your own words. And so what I just want you to write here is that to find the next number, you are just going to take 2 times the previous number. 2 times the previous number will give you the next number. This is what a recursive function is, or a recursive formula. It's just saying to find the next one, you're going to do 2 times the one before it. All right, number 2. So write the recursive formula for g sub n given this sequence. So recursive formula, look back up at the top. Look at your recursive formula. G sub n is r times g sub n minus 1. That is our formula. Make sure you pull that from your formula and always write that down. So what do we need for that? We need r. And so how do we find r? That's the common ratio. What are we multiplying by each time? And so we're going to take the second term divided by the first term. And we're going to take the third term divided by the second term. And we type those in, or we reduce them ourselves, and we can see that that is 1/2. We are multiplying by 1/2 each time. You may notice that we are also dividing by 2. That is the same thing. Divide by 2 is the same as multiply by 1/2. And we have to do 1/2. Common ratio means what are we multiplying by? So once we get that r, we can write our recursive formula. So g sub n is 1/2 g sub n minus 1, the 1 before it. There's your recursive formula. All right, now the explicit formula for g sub n, giving this new sequence, and then find the 20th term. And actually, I take that back. We are not going to find the 20th term because it's really, 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 really big. Instead, we are going to find the 10th term. So change that 20th term to a 10th term. And let's write down the explicit formula. Before we use the explicit formula, we're going to write it down. And it's at the top of our note sheet. So g sub n is g sub 1 times r to the n minus 1. That's our formula. And so we need r. We always need r. We're always talking about the ratio. And that is the second term divided by the first term. So here, what are we multiplying by each time? Sometimes these are easy to see. You can figure them out. And then double check. 15 divided by negative 3 should be the same as negative 75 divided by 15. Should be the same as 375 divided by negative 75. And all of those are negative 5. So you can see here we are multiplying by negative 5 each time. And that is our sequence. So r is negative 5. That's our common ratio. And then for the explicit formula, we also need g sub 1, which is our first term, and that first term in the sequence is negative 3. And so we plug into our formula. G sub n is the first term, negative 3, times r, negative 5, to the n minus 1. That is the explicit formula. That allows us to find any term. And now in this case, we want to find the 10th term. That means n is 10. So the notation for that is g of 10. G sub 10 means we're looking for the 10th term. And that means n is 10. So we're going to plug into the formula we just found, negative 3 times negative 5 to the 10 minus 1. So go ahead and type that into your calculator. And when you type that in, you should get 5,859,375. So you can see why finding the 20th term would have been a huge, huge, huge number. So the 10th term, pay attention to the notation here and pay attention to what we need to plug in and what we need to leave. All right, next one. Now we're talking about things in function notation. So notice this says f of n instead of g sub n, but this is just function notation. And hopefully you can also see this is our exponential function. We have 6 as our starting amount. This is our a times b to the x. Okay, these are exponential functions. That's why it's in this unit. So first thing we're going to do is this is our function that allows us to find any term, and we need to find the first 3. So first we need to find n sub 1, or n is 1, the first term. So f of 1, the first term, is 6 times negative 1/2 to the 1 minus 1. You can do that in your head or type that in the calculator, but you end up with 6. And again, this is our exponential function. Remember when we did word problems, this 6 here was our starting amount. So all of this is connected. That 6 is our starting amount. All right, so that's when n is 1. So that's the first term. The second term, f of 2, is going to be 6 times negative 1/2 to the 2 minus 1. So again, you can put that into your calculator, or you can do that one in your head. That one's not too tough, and we get negative 3. And now let's find the third term. So when n is 3, we have f of 3 is 6 times negative 1/2 to the 3 minus 1. We type that into our calculator or do that in our head, and we get positive 3/2. So what are our first three terms of the sequence? Our first three terms are 6, comma, -3, comma, 3/2. And hopefully you can see the connection there to our exponential formula. 6 is our starting amount. -1/2, that is our R. And that is how we go through and calculate our different values of the sequence. Okay, then we need to find the 12th term, which means we're finding when n is 12. So the 12th term is f of 12, which is 6 times -1/2 to the 12 minus 1. And if you go ahead and type that in your calculator, you should get for the 12th term, f of 12 is -0.00146 with a bunch of other numbers there. And that's our 12th term. Okay, last problem is to find the recursive function in two different ways for this sequence. So again, we write down the formula that we're going to use, the recursive formula. G sub n is r times g sub n minus 1. That's our recursive formula. And like every problem we've done, we need r first. So get that r, that is the second term divided by the first term. Should be the same as the third term divided by the second term. Those reduce to -1/4. So r is -1/4. So we need to do our recursive function, not formula. This needs to be in function notation. That means we are looking for f of n. And again, if we look back at the top in our box, f of n following the recursive formula is the ratio r times the one before it. That's all that is saying, r times the one before it. So f of n is going to be -1/4, that's our common ratio, times the function before that, or the term before that. So the term before n is n minus 1. Or we can say, okay, what if you want to find the next term, n plus 1? That's going to be -1/4, the previous term of that, which is f of n. So these are two different ways to write in function notation. So pay attention when we're talking about function in number 4 and 5 versus the formulas in numbers 2 and 3. That's a big distinction, so make sure you're paying attention to that. All right, go ahead and get going on your Delta Math. Remember, there are videos in Delta Math and worked out examples if you need extra help. Have a great